Alright, hello everyone, welcome back. I'm your friend in XO. Today we are going to know the negative numbers and coordinate plane. But to be honest, that's two different things. It's totally different. And for the negative, let's have a look at the introduction.
In this video, I want to familiarize ourselves with negative numbers and also learn a bit of how do we add and subtract them. And when you first encounter them, they look like this deep and mysterious thing. When we first count things, we're counting positive numbers. What does a negative number even mean? But when we think about it, you probably have encountered negative numbers in your everyday life. And let me just give you a few examples. So before actually I give the example, the general idea is a negative number is any number less than 0. Less than 0. And if that sounds strange and abstract to you, let's just think about it in a couple of different contexts. If I have we're measuring the temperature. It could be in Celsius or Fahrenheit. Let's just say we're measuring it in Celsius. So let me draw a little scale that we can measure the temperature on. And so let's say that this is 0 degrees Celsius. That is 1 degree Celsius, 2 degrees Celsius, 3 degrees Celsius. Now, let's say that it's a pretty chilly day, and it's currently 3 degrees Celsius. And someone who predicts the future tells you that it is going to get 4 degrees colder the next day. So how cold will it be? How can you represent that coldness? Well, if it only got 1 degree colder, we would be at 2 degrees. But we know we have to go 4 degrees colder. If we got 2 degrees colder, we would be at 1 degree. If we got 3 degrees colder, we would be at 0. But 3 isn't enough. We have to get 4 degrees colder. So we actually have to go one more below 0. We have to go one more below 0. And that 1 below 0, we call that -1. We call that -1. And so you can kind of see that the number line, as you go to the right of 0 on the number line, it increases in positive values. As you go to the left of the number line, you're going to have -1. Then you're going to have -2. You're going to have -3. And you're going to have, depending on how you think about it, you're going to have larger negative numbers. But I want to make it very clear. -3 is less than -1. -3, there is less heat in the air than -1. It is colder. There's less temperature there. So let me just make it very clear. -100 is much smaller than 1. Or sorry, much smaller than -1. You might look at 100 and you might look at 1, and your gut reaction is say, wow, 100 is a much larger number than 1. But when you think about it, -100 means there's a lack of something. -100, if it's -100 degrees, there's a lack of heat. So there's much less heat here than if we had -1. Let me give you another example. Let's say in my bank account today, I have $10. Do this in a new color. So let's say today I have $10. Now let's say I go out there because I feel good about my $10, and let's say I go and spend. Let's say I go out there and I spend $30. And for the sake of argument, let's say I have a very flexible bank, one that lets me spend more money than I have, and these actually exist. So I spend $30. So what's my bank account going to look like? So let me draw a number line here, and you might already have an intuitive response. I will owe the bank some money. So let me write this over here. So tomorrow, what is my bank account? So you might immediately say, look, if I have $10 and I spend $30, there's $20 that had to come from someplace. And that $20 is coming from the bank. So I'm going to owe the bank $20. And so in my bank account, to show how much I have, I could say 10 minus 30 is actually -$20. So in my bank account tomorrow, I am going to have negative $20. So if I say I have -$20, that means that I owe the bank. I don't even have it. Not only do I have nothing, I owe something. It's going in reverse. Here I have something to spend. No one owes, if to some degree, if my $10 is in my bank account, means the bank owes me $10. I have $10 that I can use to go spend. Now all of a sudden, I owe the bank. I've gone the other direction. We use a number line here. It should hopefully make a little bit of sense. So that is 0. I'm starting off with $10. And spending $30 means I'm moving 30 spaces to the left. So if I move 10 spaces to the left, if I only spend $10, I'll be back at 0. If I spend another $10, I'll be at -10. If I spend another $10 after that, I will be at I will be at negative 20. So each of these distances, I spent $10, I'd be at 0. Another $10, I'd be at negative 10. Another $10, I would be at negative 20. And this whole distance right here is how much I spent. I spent $30. So the general idea, when you spend or if you subtract or if we're getting colder, you would move to the left of the number line. The numbers would get smaller. And we now know they can get smaller than 0. They can go to negative 1, negative 2. They can even go to negative 1.5, negative 1.6. You're getting more and more negative the more you lose. If you're adding, if I go and get my paycheck, I will move to the right of the number line.
So the negative is let's say a basic idea opposed to the positive, and let's say every negative numbers, it has to have a sign this before that kind of number. For example, 5 or negative 10 or something like that. It's a basic idea that you need to understand, because in real life or in some simple programming, you have to deal with a negative. Then it comes with absolute value. It's a strategy or a method to convert the negative numbers to a positive number, so that we can get let's say a length, something like that.
Let's say that I have two numbers on a number line right over here, and the two numbers on my number line that I care about, the number A and the number represented by B here. And the way I've drawn it, B is to the right of A on our number line, and by our convention, B is going to be greater than. If I wanted to figure out the distance between A and B, what is going from A, this distance going from A to B right over there, how would I figure it out? Well, I could just take the larger of these two numbers, which is going to be B, and then subtract out the smaller. So I subtract out A, and I'll be left with this distance, and this will give me a positive value. When I want a distance, I should think in terms of a positive value. How far apart are these two things? But I was only able to know to do B minus A because I knew that B was greater than A. This is going to give me a positive value. What if I knew that A was greater than B? Well, then I would do it the other way around. Let me draw that again. Or let me draw another number line right over here. And in this world, I'm going to make A greater than B. So is B, that is A. If I wanted to calculate the distance between B and A here, well, now I would take the larger of the two, A. Remember, I want the positive distance here, and then I would subtract out the smaller. I would do A minus B. Well, so here I did B minus A, here I did A minus B, but what if I didn't know which one was greater? If I didn't know whether B or A was greater, what could I do? Well, what you could do is just take either A minus B or B minus A and take the absolute value. And if you do that, it doesn't matter if you take B minus A or A minus B. Turns out that regardless of whether A is greater than B or B is greater than A or they're equivalent, the absolute value of A minus B is equivalent to the absolute value of B minus A. And this is equivalent, either of these expressions is the distance between these numbers. And I encourage you to play around with the negatives, factor out some negatives, and think about the absolute value, and it'll actually make a lot of sense why this is true. In another video, I might do a little bit more of a rigorous justification. But I think the important thing for this video is to see that this is actually true. So let's say we're in a world, get a number line out. Let's look at some examples. So let's say that we want to figure out the distance between.
Okay, I guess it's unnecessary. Let's use Python to solve this out. So for example, now if we got A equal to negative 20 and B equal to, let's say, equal to 1. What's the distance between A and B? I could do A minus B, but we get a negative number which isn't negative. A negative number doesn't represent the distance, so we need to convert it to an absolute value. How can we do that? We could say absolute with A minus B, and in the end we would get 21. That's exactly what we want. And I can make it more abstract, more obvious. For example, if we give the absolute function a negative number, like let's say negative 2, we will get the 2, and we can do this for many times as we like. We can give it negative 100 and it will give us 100. But if we give it a positive number, it will return the same number to us. So absolute value of 5 would be exactly equal to 5. That's true. So basically, this is the idea of absolute value. And here he's talking about the multiplying and dividing negative numbers. So we can also do that kind of experiment with Python. For example, negative 2. Let's say that's 2 times 5 equal to 10. How about the negative 2 times 5? Well, it's equal to negative 10 because we got 1 negative here, and in the end we get 1 negative here. But for negative 2 times negative 5, we'll get, what kind of value we would get? We would get 10 because, now we got two negative numbers and we can write it down, negative, and 2 times 5 is probably equal to 10. Yeah, that's correct. Because a negative value of a negative value, for example, like 2, it will cancel out the negative, and in the end it will become the positive, just like what I said. But my explanation wasn't that, let's say, intuitive. So we'd better have a look at his video.
Let's say that you are an ancient philosopher who is building up mathematics from the ground up, and you already have a reasonable understanding of what a negative number could or should represent, and you know how to add and subtract negative numbers, but now you are faced with a conundrum. What happens when you multiply negative numbers? Either when you multiply a positive number times a negative number, or when you multiply two negative numbers. So for example, you aren't quite sure what should happen if you were to multiply, and I'm just picking two numbers where one is positive and one is negative. What would happen if you were to multiply 5 times negative 3? You're not quite sure about this just yet. You're also not quite sure about what would happen if you multiply two negative numbers. So let's say negative 2 times negative 6. This is also unclear to you. What you do know, because you are a mathematician, is however you define this, or whatever this should be, it should hopefully be consistent with all of the other properties of mathematics that you already know, and preferably all of the other properties of multiplication. That would make you feel comfortable that you are getting this right. And later we can think about other ways to get the intuition for what these might be and why it actually makes sense. But to make this consistent with the rest of the mathematics that you know, you go into a little bit of a thought experiment. You say, well, what should 5 times 3 plus negative 3 be? Well, you already have a philosophy of adding negative numbers or adding positive to negative numbers. You know that negative 3 is the opposite of 3. If you add 3 to negative 3, you're going to get 0. So this is going to be equal to 5 times 0. 5 times 0, based on how you already thought about adding a negative to a positive. And anything times 0 is going to be 0. So this expression right over here should be 0. But on the other hand, you say, well, I want multiplying positive and negative numbers to be consistent with the distributive property. So I should be able to distribute this 5. And for math to be consistent, and math should be consistent, I should get the exact same answer. So let's distribute this 5. So if we get 5 times 3, so 5 times 3 is going, let me write it out. This is going to be 5 times 3. Let me write it with the multiplication, not the dot. I'll write the X sign for multiplying. 5 times 3, so I distribute it there, plus 5 times negative 3. And I'll do that in yellow. 5 times negative 3. 5 times negative 3. And this whole thing we just said should be equal to 0. This should be equal to 0. Well, 5 times 3, those are two positive numbers. We know what that should be. That is going to be 15. So now we get this thing, 15 plus whatever 5 times negative 3 is, plus whatever 5 times negative 3 is, needs to be equal to 0 in order to be consistent with all of the other mathematics that we know. Well, what plus 15 is going to be equal to 0? Well, the opposite of 15. In order for this to be true, in order for this to be consistent with all of the other mathematics we know, this right over here needs to be equal to negative 15. And so you say 5 times negative 3, in order to be consistent with all the other mathematics we know, needs to be equal to negative 15. And that's also consistent with the intuition of adding negative 3 repeatedly 5 times. Now, a slightly harder to conceive idea is multiplying two negatives. But we can do the exact same thought experiment. We want whatever this answer to be consistent with the rest of mathematics that we know. So we can say, we could do the same thought experiment. What would negative 2 times 6 plus negative 6 be equal to? Well, 6 plus negative 6 is going to be 0. Negative 2 times 0, anything times 0 needs to be equal to 0. But then once again, we can distribute. We can distribute negative 2 times 6. So we get negative 2 times 6 plus negative 2 times negative 6 plus negative 2 times negative 6. And once again, all of that's going to need to be equal to 0. Now, based on the thought experiment we just did, we said, well, this needs to be equal to negative 12. Or we could view this as going to the 6 twice in the left direction on the number line, which would get us to negative 12. Or you could say repeatedly adding negative 2 6 times. That would also get you to negative 12. And now we also saw it over here, that we multiplied a positive times a negative. We got we got the negative. So this could be, or we know that this is going to be equal to negative 12. And so we get negative 12 plus whatever this business is going to have to be equal to 0, in order to be consistent with all of the other mathematics that we know. And so what plus negative 12 is going to be equal to 0? Well, positive 12 plus negative 12 is going to be equal to 0. So this needs to be equal to positive 12 in order to be consistent with all of the other mathematics we know. And so there we get the idea that this is going to be positive 12. I'll leave you there, and I'll see if I can make a few other videos that can also give you a conceptual understanding of why these are true. Let's say that...
So, as I could say, the idea for his solution is that he didn't know the solution or didn't know the answer before, but he tried his best to get the right answer from something that he already know without breaking the old systems or old mathematical systems that he know. That's a genius idea, and to be honest, that's a way to actually get some new knowledge from the nature or from the unknown. Here's another idea called coordinate plan. As far as I know, this is very important because without this kind of mathematical concept, you won't be able to see my video now, and you will not be able to see this web page or my computer desktop, because the whole, let's say, the 2D system are based on the coordinate plane. Oh, you probably do not know what is 2D. Oh, 2D means two-dimensional world. I don't know how to explain to you. Let's say, for example, for now, we got my desktop, and I could draw a plan, 2D plan. At the center, I could define a point where it's equal to 0, comes with 0. And I could draw a few stuffs, and I would call this line X, and I would call the vertical line Y. And for the X, it could be 1, 2, 3, 4. For the Y, it could be also called 1, 2, 3, 4, and so on. Of course, as you have already learned the negative, you could also draw the negative line. So now it's quite obvious that why you need to master the concept of negative, because you have to use it in the 2D plan. And how can I, let's say, represent this point in this plan? Well, as you could say, at the x axis or this line, we get 2. Then at the vertical line, the y-axis, we get also 2. So this point can be represented as 2 and 2. And we can even, let's say, go on. How about this point? From the x-axis, we get negative 2. But for the y-axis here, we got 3. So this point can be represented as negative 2 and 3. You know, my explanation wasn't that good, so let's have a look at his explanation.
What we're going to do in this video is, through a bunch of examples, familiarize ourselves with the xy coordinate plane. And first, we're going to just look at some points that are already plotted and figure out their coordinates. Then we're going to look at some coordinates and figure out where those points are. And then we'll do one more problem. So let's figure out what are the coordinates of these points. So you have this point right here, A. So it's x coordinate. You can see it right there. You just drop down. Where does it intersect the x-axis? X is equal to 5. Point 5, comma, and y is going to 6. 5, comma, 6. Now this point B here, it's the x-coordinate. It is 5 to the left. 5 to the left of the x-axis, negative 5. X-axis coordinate is negative 5. Y-coordinate is, go straight to the right. You're going to hit y is equal to 5. Y is equal to 5. Colors. C. I think you're getting the hang of this. Let's do the y-coordinate first. The y-coordinate is 3. You see that right there. And then the x-coordinate is negative 2. Negative 2. You always put the x-coordinate first. That's just the convention we use. D. X-coordinate, negative 2. You see that right there. Y-coordinate, negative 2 as well. Get another color. E. D. Let's do the y-coordinate. Well, we'll figure it out first, but you always have to write it second. Negative 4. You see that right there, the y coordinate. The x coordinate is 3. And then finally f. X coordinate is 2. The y coordinate is -6. Hopefully that gives you a sense of at least figuring out the coordinates. Now let's go the other way. Let's start with coordinate, figure out where those points are. So you have this first one. I'll do it lowercase a in parentheses to differentiate it from this uppercase a. So it's at 4, 2. X is equal to 4. Y is equal to 2. X is equal to 4. Y is equal to 2. That's that right there. Do the next one. Do it in a color that you'll be able to read. B. X is equal to -3. X is equal to -3. Y is equal to 5.5. All the way up to 5.5. Right? Y is equal to 5.5. That is the point lowercase b with parentheses around it. Then C. 4, -4. X is equal to 4. Y is equal to -4. Right over there. And then one last one. I'll do it in orange. D. X is -2. Y is -3. X is -2. Y is -3 right there. That's the D with parentheses. And you could have gone the other way. You could have said, hey, y is equal to -3, x is equal to -2. So you could go to the left and down, or you could go down and to the left, and you're still going to get to the same point. So hopefully that gives you a good sense of how to figure out coordinates, or if you're given coordinates, how to figure out where to plot something on the xy coordinate plane. Now let's do a slightly more involved problem. It says the following 3 points are 3 vertices of square ABCD. Plot them on a graph, then determine what the coordinates of the 4th point D would be. All right, let's plot these on a graph as they tell us to do. All right, that'll be my y-axis, vertical axis. That'll be my x-axis. And let me put some, mark it, so that's x equals 1, 2, 3, 4. Then -1, -2, -3, -4. That's y is equal to 1, 2, 3, 4. Y is equal to -1, -2, -3, -4. Right, y equals 4. That's y equals -4. 4. X is equal to -4. And let's plot these points. So first we have the point A is equal to -4, -4. So we go x is -4, and then y is -4. So we drop down 4 right there. That is our point A. -4, -4. And just to familiarize yourself with a labeling scheme that you may or may not have seen before, is that people label these sections of the coordinate plane. They call this the first quadrant, call this the second quadrant. They call this the third quadrant, and they call this the fourth quadrant. And these are just the Roman numerals for 1, 2, 3, and 4. So this point is in the third quadrant. We look at this stuff over here. These points are in the fourth quadrant. These are in the third, second, first. Just an interesting thing to know. Sometimes someone might ask you, what quadrant is that point in? And you just say, oh, okay, I see. If they're both negative, they're going to be in the third quadrant. If just the y is negative, but the x is positive, you're going to be in the fourth. If they're both positive, you're in the first. If y is positive, but x is negative, you're in the second. And we'll talk a little bit about that. Point B, x is positive. It's 1, 2, 3. And y is -4. So we drop down here into the fourth quadrant. That is the point B, 3, -4. So we can already see the bottom of our rectangle that they're talking about right there. And notice, both of these have the exact same y. They're both at the same level below the x-axis. And then what's the next point? Point C is 3, 3. So 3, 3. It's in the first quadrant. Both of its coordinates are positive. 3, 3. Both x and y are positive. And notice, it's on the same vertical as B. It has the same x value. They both have an x value of 3. So it's right above it, right above it. Now we have to figure out the last point here. Well, the point is going to have to be on the same vertical as this point. It's going to have to be on the same vertical as this point, which means it's going to have the same x value as this point. So the x value is going to be -4. And then it's going to have to be on the same horizontal as this point. It's going to have to be on the same horizontal as that point. So it's going to have the same y value. It's at the same height above the x-axis. It's going to have to be 3. So that is our point D. Notice it's at -4, right above A, and it's at y is equal to 3, right to the left of point D. And we are done.
Let's look more videos to get more ideas about this. But the concepts, let's watch it first.
The following graph represents the first 5 terms of 2 given patterns. In the answer box, there are different statements about the 2 patterns. Choose all correct statements. So here for each point, this point right over here, this represents its horizontal coordinate is the first term of pattern A, which is 4. And its vertical coordinate is the first term in pattern B, which is 1. And then we could do that for the other points as well. So actually, let's figure out what the values are. So we have pattern A, and then we have pattern B. So the first term for pattern A is 4, and when pattern A is 4, the first term for pattern B is 1. The second term for pattern A is 7, and when pattern A is 7, pattern B is also 7. Third term, pattern A is 10, and pattern B is 13. And then fourth term, pattern A is 13, and pattern B is 19. And then finally, fifth term, pattern A is 16, and pattern B is 25. Now, before even looking at these, let's see what we can think about these patterns here. So it looks like pattern A starts at 4, and it increases by 3 every time. To go from one term to the next, you just have to add 3. Now, what about for pattern B? Pattern B starts at 1, and every term here, it looks like you're adding 6. So when pattern A increases by 3, and we're moving in the horizontal direction, based on the fact that pattern A is represented on the horizontal axis, we're going to move up 6 in the vertical axis, and we see that here. Pattern A increases by 3. Pattern A increases by 3 from one term to the next. And when that increased by 3, pattern B increased by 6 from one term to the next. Pattern B increased by 6 from one term to the next. And we see that it keeps doing that. Now let's think about what we have over here to see which of these statements actually apply to this. For every term in pattern A, multiply the term by 2 and then subtract 7 to get the corresponding term from pattern B. So let's see if that holds up. So according to this, if this was true, I should be able to take this, multiply by 2, and subtract 7 and get that. So let's see. Is 1 equal to 2 times 8 minus 7? Or sorry, 2 times 4 minus 7. 2 times this number, 2 times 4 minus 7. Well, 8 minus 7 is equal to 1. Is this right over here equal to 2 times this 7 minus 7? Well, yeah, it's equal to 7. Is 13 equal to 2 times 10? 2 times 10 minus 7. Yeah, 20 minus 7 is 13. Is 19 equal to 2 times 13 minus 7? 26 minus 7 is 19. Is 25 equal to 2 times 16 minus 7? Well, 32 minus 7 is 25. So this first statement checks out. For the corresponding term, the value of pattern B is 2 times the value of pattern A minus 7. Now let's look at the second one. The terms of pattern B are always greater than or equal to their corresponding terms from pattern A. Well, no, that's not right. It's true for a couple of scenarios. Here, for the third, fourth, and fifth term, or actually for the second, third, fourth, and fifth terms, pattern B is equal to or greater than pattern A. But for the first term, it's not true. Pattern A is greater. So this is not right. To get from each point to the next, you need to move 3 units to the right and 6 units up. Well, that's exactly what we talked about. From one term to the next, pattern A, along our horizontal axis, we increase by 3, while pattern B, we increase, which is plotted on our vertical axis, by 6. So you move 3 to the right and 6 up. That is right. The second terms of both patterns are 7. Well, yeah, we see that right over here. The second terms are 7. We have 7 here, and we have 7 there. And so that is right as well. So the only one that doesn't apply is this second one. This is not.
Okay. To be honest, if you want to get the whole idea in a detailed way, if you are just a beginner and didn't know those concepts before, you definitely should look at those videos one by one without skipping any of them. Otherwise, you probably will get confused. But for me, since these are basic ideas that I have learned a long time ago back to my childhood, so I think it's okay to skip those videos.
Below are ordered pairs.
Anyway, that's today's learning for the mathematics. And inside of this video, we have learned the concept of negative numbers and what is the absolute value, and let's say what is the coordinate plane, and how can we represent a point inside of that coordinate plane. Basically, we have two, let's say, we have two property for that point, x and y. And sometimes people will not call this x, they would call whatever len for it, but as I always said, a point would be represented by two properties, this one and this one, no matter what len it is. So that's why people call it 2D coordinate, because it literally has two property for that for each point inside of that plane. Okay, that's today's learning, and I'll see you guys in the next video. Bye.